Western countries, what happens is they don't much follow the examination system. Instead, they will have the assignment kind of system, where you do more and more projects. For example, in my MS, for the 8 or 9 subjects I got, I only had one written exam. For the rest of the 9, it was a project. I do a project and I will submit, and that will be evaluated, and that will be, scored, rather than me sitting in examination and writing an exam. So it changes from country to country. We follow most of the British system because for whatever our history is. But in other North American countries like America and Canada, they follow this, submission of assignments, that kind of system, isn't it? So for these people, like the creation of content also is electronic, also is web-based, also is mobile, ready. And from this angle, the student's angle also, it is the consumption of the content also happens through these methods. So this is a little bit futuristic. Maybe 10 years from now, 15 years from now, you will see the situation where everything happening through, electronic data transfer. Okay. So we have seen why Android has come into the picture. Why in what way it is better than iOS and other Windows and BlackBerry and other mobile operating systems. We have seen what we can do with Android. That is the making of applications, making of games, right? So you make an application, you make a game. Most probably it is for the society. It's like just you are making a product in a company. After finishing the product, what you do is ideally you take it to the market, isn't it? It's the same thing. Android also, you make an application, you put it in the Google Play. People like your app, they'll download it, use it, and give you a feedback also in terms of rating. And luckily, if your app is impressive, it gets good rating, you will have thousands of downloads. And every download, they'll see money. Okay? So that is a full circle of development. Now we'll start the technical side of Android a little deeper. So you guys, since you being a ECE students, you can understand the stack. So this is the stack. As far as Android is concerned, this is the stack. Now, the most basic layer on hardware is your Linux kernel. Okay? So your Linux kernel is having all this, display driver. This is what I said, the device driver of OpenGL, which will make your graphics look richer. Okay, so all the drivers, everything will sit in that kernel, Linux kernel. On top of it are Android libraries, but system libraries. Okay, these things. And runtime to compile and run your application, because Android is more of Java technology based. Okay. And the layer above it is application framework. This is accessible to the developer. Okay. You are making application with this layer. Whether you will make a your own app will come in this extra somewhere, but the device manufacturer himself has made all this for you. Your app, Android mobile, will definitely have a browser, maybe Chrome, Google Chrome could be, and then it will have a phone app, it will have a contacts app, it will have your menu screen app. So these things are what we are interacting with, what we are using for our daily work. But what it's doing is in turn going to one of or more of these level frameworks to do that job for you. Say for example, location manager, right? Yeah, location manager. So this location manager is for your GPS. Your phone is having Google Maps installed in it, right? You have activated your data connection, 2G data connection. And now you open up Google Map, it is readily picking up your current location. You are giving your, say like just now, when I am coming my way to here, I give it my current location directly to Peri Institute of Technology. So it plotted the way for me, isn't it? So how internet is doing it, how Android is knowing where you are, isn't it? So that location-based services, it's called LBS, location based services, all mapping related thing that will be handled by your location manager. So there is one specific framework to handle each, like telephony manager will take care of all your phone related applications. Calling, all of your phone, the green phone icon bottom you are seeing on your Android phone, which is kind of serving all your telephony requirements, making calls, receiving calls, all that. When you use the phone app, it is internally reaching up to this telephony manager, and like a wrapper, this telephony manager will take care of all your requests, will process and will give you. Okay. Rest of the things, window manager or view system, these things are like how the actual view is organized. That we will see in the next slides. Okay, so that's about the stack. Here in this level also you can see OpenGL is, as I said, OpenGL for embedded systems. Normal desktops will run OpenGL, the common version, but ES is a little subset of it. It's like for embedded systems like mobiles and tablets or any other handheld devices like smart navigation systems and other things. Because here your memory is constrained. When you are talking about a smartphone, your memory, now of course the situation is changing that you are having even a 2 GB RAM in mobile phones. But I am talking about when the mobile phone, the concept of mobile phone itself has started. When we are making apps in GTME per SMAAT, the installer that we are allowed to put should be around some 250 KB. 250 KB is so small a size, you guys can understand that, right? So in that kind of constrained environment, if you are making something to run, the basic expectation is that you will utilize the minimum amount of resources, minimum amount of battery time, because you are carrying a mobile phone and its battery, say like you charge it fully 100%. But that 100% is kind of being shared by all the services inside your mobile phone, right? First thing is your telephone. It will always show the signal strength. So it's in standby. Somebody calling you, you are receiving a call and you are talking, right? So your telephony is running something constantly to check where any call is coming, any call is coming, right? So like that, there are so many other services which are constantly running, just like your view. Whenever you open a phone, smartphones are a little, that's why it's called smartphone. When you are using, it will grow the screen and some 10-15 seconds of idle time, it will switch off the screen. But if the device is not that smart, if the screen is growing all the time, naturally it will consume a lot of battery power, isn't it? So like that, when you are trying to make a mobile application or a handheld application, the first thing you have to worry about is the limited battery time that you got, limited resources you got. Okay? But luckily, while it's evolved so much, what I was talking about is the days that SMAAT was ruling. Now we have come to a level where hardware profile, like RAM and other things, processor speed, these things are much comparable to the desktop. So now maybe it's not that important. When you guys start learning Android and working it might not be a big concern for you guys to make your programming focus on that part. Okay? But in general, that is the methodology. Because mobile phones are inherently expected to be away from a charging point for most of the time. Right? We compare with the desktop. Desktop always will have a socket, plugged into the power point, power socket, and every time it will like AC current is taking. So you will never have a situation where desktop has ran out of power, unless of course you have power cut or something. But whereas a mobile phone, you are after a certain amount of time you are disconnecting it from the charger. Now you are carrying it in your hand. So the battery that is holding that charge is kind of, as I said just now, it's serving all the services that are being constantly running inside the mobile phone. So now when you make an application to put it in a mobile phone, you have to understand that your application should not